What became of the dinosaur-killing asteroid? An asteroid the size of Mount Everest struck Earth around 66 million years ago, triggering a cataclysm that wiped out 75% of the living creatures. But how are we aware that it took place? Where is that enormous meteorite, if it exists? Have we located it? Let's investigate. Introduction: the English physician Gideon Mantell, recognized as the first dinosaur fossil in history. Starting at that time, approximately the globe, we were discovering more remains of animals that humans had never seen before. Prehistoric animals. These well-known animals that have drawn interest from both young and old have existed for a very long time. There was a wide range of sizes and shapes among the earliest humans to set foot on Earth. The most puzzling aspect about dinosaurs is that, in spite of their diversity and massive size, the majority of them are now extinct. Why did these enormous animals that once roamed the entire Earth go extinct? For many years, scientists all throughout the world asked themselves this question. The mysterious mass extinction of the Cretaceous-Paleogene. The mysterious mass extinction of the Cretaceous-Paleogene in the 1990s, geologists and paleontologists globally, significant attempts were undertaken to unravel the mystery behind the extinction of dinosaurs. Several trips were made to the most important fossil in the globe during this time. Regions of extraction, and researchers discovered a pattern in every dinosaur sample. Scientists discovered that dinosaurs ceased to exist when determining their age. It indicates that the majority of dinosaurs perished at a specific point in time in history. Stated differently, geological data indicated that an abrupt mass extinction occurred 66 million years ago, brought about the end of the Mesozoic era and the Cretaceous epoch, resulting in the Paleogene, the initial stage of the Cenozoic era, which is still active now. The Cretaceous-Paleogene period, or KPG event, was used to identify this unexplained global extinction. The KPG event is identified in the geological record by a thin layer of sediment known as the KPG boundary, which is present in terrestrial and marine rocks all across the world. Oddly, the KPG border clay exhibits remarkably elevated quantities of metallic iridium, an element found in asteroids more frequently than in the crust of the Earth. An absolutely hard thing to find. An absolutely hard thing to find. 1980 saw a team of scientists headed by physicist Luis Alvarez, his son Walter Alvarez, a geologist, and other associates found in samples the Cretaceous and Tertiary periods intermediate strata, as seen from all throughout the world. Iridium content hundreds of times higher than typical 65 million years ago. This discovery led to the development of the Alvarez hypothesis, which explains why there was an extinction of dinosaurs and numerous other organisms would have resulted from the collision of a massive meteorite striking the Earth's surface 65 million years ago. Although this theory encountered an issue, the issue was that a meteorite of that size would have left a crater if it had wanted to trigger a mass extinction of the Earth's crust that is at least 150 kilometers in diameter. Up until that point, no crater of such dimensions were recognized. Chicxulub crater. Chicxulub crater to support the hypothesis that dinosaurs possessed fall extinct as a result of an asteroid strike. It was vital to locate the crater where it had collapsed. Geologists from all throughout the world diligently sought the well-known crater without any luck. Given that the event occurred 66 million years ago, this was a challenging task because, at that time, given that the continents did not have the current configuration, it is most likely that the crater was buried many kilometers below the surface. How can one locate an invisible crater? Luckily for geologists, a Mexican had already unintentionally discovered the crater. Company several years prior. In the 1970s, parastatal engineers Glenn Penfield and Antonio Camargo, geophysicists, in the Gulf of Mexico, the company Petróleos Mexicanos, Pemex, discovered a gravimetric anomaly. This anomaly, which extended many kilometers in depth, was discovered while searching for oil resources via the state of Yucatan and the Gulf of Mexico. At first, engineers were unsure of the structure's identity, but it resembled a crater left behind by a meteorite strike. NASA and the National Autonomous University of Mexico, UNAM, conducted an analysis. The well samples that the Mexican business Pemex drilled in order to support this notion. As a result, they calculated the diameter and dimensions of a crater that was deeper than 2.5 kilometers. More than 200 kilometers, the planet's largest and best-preserved crater at the moment. This crater's center is situated close to the coast, several kilometers east of Puerto Progreso, the Yucatan state's town of Chicxulub. As a result, the crater was given the name Chicxulub. Upon hearing this news, the Alvarez researchers headed straight to the crater. Was found to investigate the iridium isotope concentrations, which they discovered to be abundant, confirming that the crater that everyone had been searching for was this one. That's where the dinosaur-killing meteorite landed. The meteorite was here, following the formal designation of the Chicxulub crater as the location of the deadly meteorite impact. The meteorite was here. There was only one thing left to do: dinosaurs. Locate the meteorite. But since there was no longer a meteorite like that, this would be a pointless endeavor. A smaller space object that strikes the planet's surface is called a meteorite. Nonetheless, this meteorite might be categorized as an asteroid or as a meteorite prior to impact, or like a comet. Massive boulders with high metal and mineral concentrations are called asteroids, whereas ice, metals, and rocks are found in comets. At first, it was thought that the Chicxulub meteorite originated from a large metallic asteroid, but more recent data indicates that the object was probably a comet. Because of the measurements made in the Chicxulub crater, it is known that the meteorite's diameter at the moment of impact had to have been between 9 and 11 kilometers. On the other hand, this would have happened at the entry if it had been a comet rather than an asteroid. By shrinking in size, a large portion of the comet's outer layers were expelled into the atmosphere, exposing its internal layers. The heat produced by the comet's impact on Earth's surface was so great that the rock and the metals that comprised it went straight from a solid to a gaseous state. That is that the impact's extremely high temperatures caused the meteorite to vaporize immediately. Furthermore, the impactor transformed the rocks into liquid, resulting in multiple enormous tsunamis, kilometers above ground. Stated differently, the meteorite broke down exactly where it had fallen. The impact of the meteorite ravaged the entire world. The impact's result: ecosystem, increasing global temperatures, and triggering earthquakes that triggered all the world's volcanoes. This resulted in a sequence of eruptions that filled the sky with. For thousands of years, the planet was covered in steam, ash, and dust. The impact heated the Earth completely at first, but it soon began to cool. Because of the smoke obscuring the sky, the swift acidification of the oceans caused an ecological collapse that led to the extinction of plants, rupturing the food chain and causing 75% of the species that had lived there to go extinct. The Earth. The plants were unable to perform photosynthesis as the sky grew darker, which resulted in them turning into gone from existence. Then, the creatures who consumed those plants, herbivores, started to perish, and the animals that were predators that ate the herbivores perished as well. The creatures that could only live were those that had an alternative food source: plant parts, like seeds or roots. The little rodents that resembled contemporary marsupials could so seek safety from the burrowing into the roots of dead plants. Ashes fall from the sky. By consuming the seeds and other more sophisticated creatures, like birds, they were able to live. Leftover nuts from the fallen trees, and looking for water in the subterranean mantles that had not been impacted by the falling ashes from the meteorite's impact. Many species were lost during the KPG extinction, with non-avian species being the most well-known. Prehistoric animals. Despite the fact that several mammals, birds, lizards, and other terrestrial creatures also perished, plants, all pterosaurs, and insects, the meteorite strike in the waters wiped out mosasaurs and plesiosaurs and severely damaged sharks, mollusks, teleost fish, and numerous species of plankton. But the extinction also presented chances for evolution, hence, numerous groups of. The abrupt absence was the primary reason of the extraordinary adaptation that plants and animals underwent. of the dinosaurs, who up until that point had ruled the planet. In the absence of dinosaurs, tiny animals started to take on new forms and dimensions within the jumbled and deserted natural niches, creating novel forms like whales, horses, and primates and bats. The only dinosaurs still alive were birds, both terrestrial and aquatic, which later gave rise to modern birds. Species. Thus keep in mind that birds are dinosaurs when people wonder what happened to the dinosaurs. It was more than just meteorite. In contrast to popular belief, it wasn't just a meteorite. Multiple impact theory, a theory that is now in use, suggests that the extinction of the dinosaurs was caused by numerous meteors falling rather than just one, everywhere on Earth. According to this view, it's possible that the comet that triggered the Cretaceous extinction shattered, broke into multiple parts, each of which dropped at a separate location on Earth. The Silverpit crater, an impact crater formed by submerged debris off the coast of the British Isles, lies the North Sea. By examining seismic data gathered during standard oil drilling, it was found in 2002. All the evidence points to the crater's age of 65 million years when it struck the Earth. Million years ago, meaning that the Chicxulub impact and its genesis occurred at the same time. Crater on Mexico's Yucatan Peninsula. In the event that Silverpit is an impact crater, this could indicate that encounters with not just one, but multiple items at that moment. However, we now understand that extinction and meteorite strikes did happen and were the reason for the dinosaurs' extinction. We are aware that this incident happened and that it will probably happen again. But when will it happen next? Asteroids similar to the one that wiped out the dinosaurs re-enter the atmosphere? Would we be able to defend ourselves against a comet similar to the one that wiped out the dinosaurs? We're only now making our way toward Earth? Please leave a comment below if you think we should create a video on that.